board with my markers. Today we're doing section 8 2B. So 8 2B, and it's called matrix multiplication. Now I'm wondering, did you guys do a little bit of this last year?
No.
Oh. Okay then. Okay, matrix multiplication is a lot of work, and it's a lot of keeping things straight, but it's not hard.
But there's a shortcut on the calculator, right?
But you do have to show on your test that you know how to do this by hand. If you know.
Well, why if we have a calculator?
Yeah, we have the calculator, we have to do it by. Yeah, you got, the school has died.
Oh my word.
No, that's a serious question. Why do I need to show my work if I can do it on the calculator?
Okay.
Yeah, that's what we have.
Let me just explain. When I was in college and I had to take all these courses on the proof things on why things work, you need to be able to verify things for yourself. Also, when I went to college, the thing that I remember the most, one statement by my freshman, it was like civics class because everybody had to take world history. It was like a civics gen ed. He said, and I'm not going to quote this word for word, but basically it was this idea. He says, I'm going to get up here and I'm going to tell you stuff. And your books are going to tell you stuff. And you have to be aware that even though I'm teaching history and we think history is just like a done deal, it's like that's what it is. You got to understand that every source that you come across, every teacher, professor you have is going to have their own bias. They're going to bring their own experiences, their own moral compass to the table. So like if you were reading an essay about the Civil War from somebody who was from the South, it's going to look totally different than somebody who was from the North or somebody who was in England. You know, everybody has their bias. And because of that, you have to verify everything. You have to question everything. Always don't just trust something's true. And you guys, you're the generation of the internet. You know you can't believe everything you see on the internet. I was talking to Mr. Bruns yesterday about statistics. You know, you think statistics should be like a black and white thing. Well, you can pull up statistics and you can skew it to prove anything you want to. So you always have to go in with the idea of, I've got to test it. Okay, so that being said, now we get to this, and you can't just always assume that I don't have to know how to do this because my calculator or the computer program or whatever does this for me. Because who's to say that that person that created that program didn't have a skewed representation of reality, right? Now I know it's a calculator and you think it should be good, but you should still always verify by understanding it yourself first. Being able to prove things yourself. Okay? So that's why we're going to learn how to, by hand, multiply matrices. Okay, now here's the deal. We talked about order on matrices, right? And they're row by column. When we multiply a matrix by another matrix, something has to be true. If I have matrix A and it is a 2 by 3, then matrix B has to have its rows have to match up with the A's columns. So it's got to be a 3 by something. So let's say it's a 3 by 4. Now you can multiply when they're not the same order. Obviously, these guys are not the same order. What is the same is the number of columns of A is the same as the number of rows of B. That has to be true. Now, what would actually be the result of this product is a 2x4 matrix. Now, remember yesterday when I said I used hangman spaces all the time for this? That's what I'm going to do here, because that's going to help me keep my computations straight or orderly. Otherwise, I get them all over the place. Now, what you do when you, okay, so if I had a 2x3 here, here, I'm just going to put letters like this, A, B, C, D, E, F. So here's my A. This is a 2x3. Whoa. This is A. And then B would be, we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is a really large one to start with, but I just want to give you an idea of what's taking place. Okay, now we said that we get a 2x4 product, right? Sorry, this thing is really glitchy lately. It's my connector. Okay, so I've got a 2x4. And I'm going to put in my hangman spaces right here. So this top row, so this would be element 1, 1, in my answer is going to be found by taking row 1 times column 1. And now what I mean by that is you take A times 1 plus B times 5 plus C times 9. And that gives you that number right there. Does that make sense? And that's why these columns have to match up with these rows. So this is row 1, column 1. And that gives us answer 1, 1. We'll actually do this with a little smaller problem right here. That's so weird that one column is really light. Okay, so do you want to do that with this one first? So since it's smaller and we have real numbers. Okay, so this is a 3x2. I always do this first. First of all, it tells me if it's even doable, because sometimes you get a no solution. And this is a 2x2. And these two numbers are the same. So this works. So that means my answer should be a 3x2 matrix. Now what I'm going to do is I'm going to make my answer really large. Actually, hold on a second. Okay. Now let's get this out of the way. And we're going to take this times this. So what does that look like? That's -1 times -3 plus 3 times -4. And when I do all the math for that, That's gonna be my element. What is it? Okay, so -9. All right, now I'm going to take row 1 by column 2. So that would be -1 times 2 plus 3 times 1. Two, is it 1? It's 1. All right. Then I'm going to take, okay, so I've got row 1 done. So I am not going to use this row anymore. That's all done. It's done its job. I will move this out of the way. Okay, so now I'm going to do row 2 twice. Row 2 times column 1. So that would be 4 times -3 plus -2 times -4. Well, 4 times -3 should be -12, right? Plus 8. Oh, I was thinking it was a -8. You're right. Okay, so that's -4. Okay. In the other slot, see if that works any better. Slot, see if that works any better. Okay. All right, so the next thing we're going to do here is take row 2 times column 2. So we're doing the same process over and over again. We just, like I said, it's not hard to do the math, but it's hard to keep track of where you're at. So that's why I always use the hangman spaces. Was that 6? Maybe? Okay. So now we're done with row 2. Now we are on to row 3. Okay, so we have row 3 times column 1. 5 times -3 plus 0 times -4. Can you kind of see why I didn't want to do this on a Wednesday? What, -15? Wow, it's so glitchy right now. And then the last one is going to be row 3 times column 2. So this would be 5 times 2 plus 0 times 1. All right, and 10. Okay, so right there is my matrix after we multiplied. All right, now notice that if we go back to the beginning, we had a 3 by 2 times a 2 by 2. So we could multiply A times B. But if I tried to flip this, and if I wanted to take B times A, And that means I would have a 2 by 2 times a 3 by 2. And since these two don't match up, this would be a no solution. So matrix multiplication is not commutative. Like every other time we've multiplied and it's like, oh, it doesn't matter which order you multiply, it's going to be the same thing. It doesn't work with matrix multiplication like that. Okay. All right, does that make sense how we did that? All right, let's take a look and see what else we have. I don't know how many examples did I have for you guys. 1, 2, 3, and no, that was yesterday. 7, 8, and 12. Okay, so here's 8. And it says, okay, so one more of these. So we have a 2 by 3 times a 3 by 2. So what should our resultant matrix look like? 2 by 2, which is nice because it gets smaller. We don't have to do as much. All righty, so the first thing we're gonna do is row 1 times column 1. So that's 1 times -2 plus 0 times 1 plus 3 times -1. -5? Is that true? Okay. Then we're going to take row 1 times column 2. 1 times 4 plus 0 times 0. Oh, that's a whole lot of nothing. And 3 times 1. Okay, 7. All right, we're done with row 1. So now we can move down to row 2. So we got row 2 times column 1. So that would be 2 times -2 plus -1 times 1 plus -2 times -1. -4. Is it 2 and -8? Yeah, -3. Alrighty, and then the last one is row 2 by column 2. So we have 2 times 4 plus -1 times 0. I'm not even going to write it because it's already nothing. And then -2 times 1. And that would be our result. Now, if you want to try it out on your calculator, just to check your answers, I would be totally fine with that. And there will be some places where it's more of the, you'll be able to use your calculator to multiply, because really what we're doing is we're trying to solve a word problem instead of like just show me that you can do this by hand kind of thing. All right, so I will state where I want you to show it by hand. Okay. Alrighty, so that was example 8. We have one more example to do. It's example 12, and I may not have covered it up yet. Nope, I didn't. Hold on. Alrighty. So here's what we have. It says 2 softball teams submit equipment lists to their sponsors. So the women's team is the first column, the men's team is the second column, and their set of equipment is bats, balls, and gloves. All right, so each bat costs $80 and each ball costs $6 and each glove costs $60. So here's what we can do. We can set that into a matrix. To find the total cost for each team. Okay, so this is a 3x2. And I want 2 to be my answer, or let's see, how do I do this? Okay, so if I put the, all right, so I could put them in a row like this, 80, 6, and 60, which would be a 3x1, right? I mean, a 1x3. And if I multiply it this way, I get a 1x2 answer, which probably would work, right? Because we want to get a total for the women and a total for the men. So we want a total of 2, right? So let's take and call this A and this B. And we're going to get a 1x2. So we're going to take this times this, which would be 80 times 12 plus 6 times 45 plus 60 times 15. Oh, I'm going to be so traditional here. For the next one, we're going to take 80, row 1 times column 2. So we're going to do 80 times 15 plus 6 times 38 plus 60 times 17. Whoa. And anybody calculate these out? I can do it here. You got it? Okay. Alrighty. So there we've got the totals for both the women's and the men's using the matrices to solve this out. I want to say, I don't know if it's in these problems or not. Okay, I'll just give you your homework and get started, and then you have some time to ask questions as you go along. So page 569, 27 through 36, and 62. And that's due Monday. And some of those, you guys, if you find the order, some of them may not be doable. So you might have a no solution. And be aware if it says A times B or B times A, because that's going to make a